In this video, we're going to look at how we can write a class to help us work with SFML, the Simple Fast Multimedia Library, a little bit more easily. So one aspect of working with SFML is drawing sprites. And so if we have a simple application like this where we've got a couple of sprites that we're loading up and drawing. We have a little space station here and a couple of asteroids and the star field in the background and a couple of other things that we've seen in other class demonstrations. The overall process is often repeated, where we create some SF texture variable, load a texture from the file, from a image file, and then create a sprite that uses that texture. And so if we're only doing this once or twice, then it's probably no big deal. But if we need to do this a whole bunch of times, especially if we need to do this across multiple files, across multiple classes or functions, creating these individual texture variables can sometimes add up and clutter our code up a little bit because these variables really have kind of one purpose. They exist solely to store these images. And so the way SFML works, and this starts to get a little bit into the behind the scenes aspect of this, where we start dealing with graphics memory and so on, and that's a little beyond the scope of the class. But essentially these variables have to live on in our program. When these variables disappear or when they fall out of scope, the file that, or the texture that's loaded and associated with that texture variable will be unloaded itself. And so basically whenever this texture variable falls out of scope, or the station variable or the asteroid texture variable fall out of scope, their destructor will unload the image that was loaded for it. And so if we try and create these in a function or in a class, in a loop or something like that, we'll have the data unloaded before our program terminates, and then we'll end up with it's something called the white square problem in SFML. And so we find ourselves with a bunch of these kind of stray or loose texture variables, and it's only 3 variables in this case, 3 lines of code. If I did something like this, well, now it's only 2 lines of code, and if I do something like this, now it's only 1 line of code, but still it's these 3 loose variables, and that can sometimes clutter our code up a little bit, especially as we have to give them all unique names. If we have a very large project where we're loading dozens or hundreds of these, we might not want to have dozens or hundreds of unique names for everything. That's why we'll do things like create arrays and so on and so forth. So if I want to avoid some of this, then one thing that I might do is store this information in a map, or specifically an unordered map, because we really don't care about the ordering of it. We're not going to sort these or anything like that. So an unordered map would be a little bit more effective here. And so if I want to use the unordered map, then I would have to include unordered map. And so I'll use strings as my key and SF texture as my value, and we'll just call this textures. And so now, instead of doing something like this, where I use my texture variable, load from file, I can instead say textures sub, or subscript, and we'll call this space. I'll do dot load from file, which is exactly this right here. And so what this is doing now is creating an SF texture at this particular location, or creating one internally that is associated with the key of space. And so an object will be created internally. That's what the map and the unordered map classes do. And then it returns a reference to that object. So then I can just get rid of this call right here. And so I could repeat this same sort of thing, and we'll call this the station, and we'll call this the asteroid. And I can now get rid of these 3 variables right here, because all 3 of those variables are being stored within this one map object, or unordered map object. And so anytime I now need to access that texture, I can just sort of look it up or retrieve it from the map object itself. And we could do something like this, and we could do something like this. Now, I think also I'm using the asteroid texture down here as well, right? So this might not seem, and we're doing the same thing right here, right, for these buttons. So let's say we'll do button clear, get rid of that, and we'll do the same thing right here. We'll just call that button new and put that right there and get rid of you. Is that it? I think that might actually one right here, texture sub asteroid. Okay. And so that might seem like a relatively simple thing, and if we run this, it should give us the same results, right? Now, what I've done is just gotten rid of, a handful of lines of code, a couple of these SF texture variables sort of sprinkled throughout my code, but now they're all stored in one location. They're stored in one variable, this unordered map variable here. And so if you're seeing this and you're thinking to yourself, okay, is that really that much better than the alternative, what was present just a moment ago? Maybe not so much, and I might find it hard to disagree with you if that's your stance right now. However, what we're going to do is expand upon this, and we're going to build a class to help manage some of these things. Even this loading process right here, I have to manually do this myself, and we can maybe streamline that a little bit. So we can write code to take advantage of what programming can do for us, and we can automate some of our own code, right? Programming and writing programs is not always just about kind of automating something external. We can sometimes write code to help us write code, which that starts to move a little bit beyond the idea of programming fundamentals, but that is a very common thing once you start getting into higher levels of programming and software development. So what I'll do here is write a class to help out with all this sort of stuff. So instead of, again, accessing this variable right here, because what if I wanted to, do this same kind of process in another class, in another file, and I don't have this variable? What could I do? Well, what I'm going to do is make a class that stores this information, and now all of these separate files could potentially just access that one class. Although in this program here, I do just have the one main file, but this would help if we were expanding this. So I'm going to come over here and just go to add and add a new class. This will just kind of speed up the process, but all this is really doing is just making a .h in a CPP file. So I'm going to call this class texture manager because it's going to be managing the creation and later deallocation of textures. So that'll make those two files for me and just create a class there. And so what this class is going to do, and let me open up the CPP file as well, which is just doing the include right there. So the big feature of this class is the unordered map with strings and SF texture in it. And we'll call this textures. And so I'll need to do a couple of includes here. So we'll do include sfml / graphics.hpp. And then we'll also include unordered map. And I'm also going to have to include string because I need that right here. And so to actually use the unordered map in the string, we'll have to do using std unordered map and using std string. Okay. And so I should also say if you are watching this video, I highly recommend that you use this approach in your own project, particularly for Project 3. This is something that I fully recommend just because it will make that aspect of dealing with SFML a little bit easier, and it's really just one less thing that you have to worry about. When working with any kind of library or API, there's always going to be some bit of a learning curve, right? Here's a tool, now you have to learn how to use the tool in order to use it, in order to put it to work for yourself. And so this right here, this texture manager class, is really just a way of kind of helping you deal with that learning curve a little bit more easily. So you can get to the good stuff. So you can get to the more challenging aspect, which is just writing the program itself. And this is just one less thing that you need to worry about. So I fully endorse your use of this class. If you want to just even skip right to the end and write this out yourself, once it's all completed, that's okay too. But learning exactly how it works is probably a good idea. And by probably, I mean it is. So something about this class that we're going to use here is we're going to use the static keyword. So static means there is one and only one of these in memory ever. So there's only going to be one texture object. And so I'm not going to want to create instances of this texture manager class, and we'll see the way that we use this a little bit later on. But because this is static, we don't need to make an instance of this. And so then in terms of functions that we have, we're going to, and also because this is static, we need to, in order to access that variable, we can only access it through other static functions. And so what I'm going to do here is do this. We'll make a function called load texture, and this texture we're going to do something like this. Pass in a texture name, just the name of a texture. So we might call load texture, and I want to load in the image called space, and that's it. Then this function is going to take care of the rest of this for me. So I'm not going to type in images/space.png. I'm just going to shorten this for myself so I can just load in the space image, and my function will handle all of the rest. And then something else that we're going to do here is another static function, and we're going to return an SF texture reference. This is the texture itself. And we'll call this get texture. And string texture name as well. And this would be, just a call like this. Same sort of thing there, right? Get rid of that actually. And then the last thing that we're going to want to do is a clear function. We want to remove all of this information. Basically get rid of all the textures that we've loaded. Call this once at the end of main. And the reason why is because I'm not going to make an instance of this texture manager class, which means it's not going to have a destructor that kicks in, and so we need to do this ourselves. Okay? Now, to use these functions, or specifically this variable, we need to do something that's a little bit unusual. When we're dealing with static functions, or static variables rather, what we have to do, let's move this over here. We have to essentially redeclare a variable, or what kind of looks like redeclaring a variable. So I'm going to do another unordered map, and this map is of strings and SF texture, and it's really this same variable right here, but it belongs in the texture manager class. And notice how when I write the texture manager class and then use the scope resolution operator, it pops up with all these static functions and variables here, and then I'm going to reference the textures variable. So what this is essentially doing here is declare the variable so this file knows it exists and can use it. And this is just something that we have to do when we're dealing with static variables. That's just the way it works in C++. And so once we've done that, then we can just basically leave it and we don't have to worry about it again. So now I can go ahead and write the rest of these functions, and I would write them, the same way that I would write any class functions. So void texture manager load texture. Oh, that takes in a string, right? So string file name. And so what I'm going to do in this particular case, what I'm going to do for this function here, like I said, I want to streamline this a little bit, so I just pass in a file name. And so I can do something like this and say, let's assume the path is going to be equal to images/. Right? Now, this might not always be the case in every program you ever write, but in the context of this particular program, this particular tool right here, this is what I'm going to use. So then what I can do is say, well, given that that's our path, let's do path plus equals file name, path plus equals PNG, right? Now we could also do this plus .png. Actually, that'll be a little bit more concise. So I'm going to take images plus whatever my file name is and then add an extension to it. So the final path, if I passed in a file name equals space, then my path at the end of all of this will be images slash space dot PNG. Right? So I get this out of just the original variable, right? So now in the rest of my program, I never need to type images / again. I never need to type my .png extension. I can just use the name of the file. This does make a couple of assumptions. I'm assuming all of my images are in the same location, which they should be for this project. I'm assuming all of my images have the same extension, which they do for this project. If those assumptions are ever not true, then you'll need to adapt, but that's okay in this particular case. So once I've done all of that, then what I could say is let's take my textures variable and do the same kind of thing that we did in main, where I'm going to say textures sub something and then load from file a path. And now notice here, space corresponds to space, station corresponds to station, asteroid corresponds to asteroid. That sounds like we could do textures sub file name dot load from file path. Okay, so now this is going to replicate what we have over here in a much more concise way. I could just call this one load texture function and all this other stuff will happen for me automatically, right? Automatically because I wrote it that way. So that's our first function that we're going to do here. And then the second function, this get texture function right here, we can, on a simple level, we could do texture, or no, that's going to return SF texture reference, get texture. Right? And so what we can do here is if we want to load this texture or just retrieve a texture, we could do on a simple level return textures sub texture name. Easy as that. So if I call get texture with the space image or space specified right here, then it will return textures sub space. Assuming it exists, right? Now, what if it doesn't exist? Right? Also, I'm getting this error here because I didn't scope this into the class itself. Right? So, what if it doesn't exist? I mean, what if the parameter to this was something like this? I accidentally hit the letter E twice, and I'm trying to return this. Well, if that doesn't exist, a default object will be created and we return that default object, right? So what I might want to do is something like what we could even do to help streamline this a bit is we could say if the texture doesn't exist, load it first, then return it, maybe something like that, right? So if the texture doesn't exist, now how would we actually find that? So we have our textures map, and what we can do is call the find function. So we can say if textures dot find, and this allows us to provide a key, and it'll search for that key. So if we try and find this texture, and it's equal to textures.end. So if we search for something and the return, because the find function returns an iterator. So if the result of this find function is equal to the bad iterator, because remember the end function when we're dealing with iterators it returns 1 past the last element, which is basically an invalid iterator. So if our find results in an invalid iterator, we didn't find it. Then what I would do is call this handy dandy load texture function that I've already written here. Load texture with our texture name. And so now when we return this, it will be loaded, assuming, again, we typed the file correctly. Now we could throw in some additional checks, and that would probably be in here, like what would happen if load from file failed, right? If that were the case, then we might need to do some other kind of checking. But let's assume, we didn't make any typos in our original file name. That will just keep this a bit simpler, right? So now we can actually just get rid of this here. And this function is now ready to go. So essentially, it's just going to do a quick check. Hey, have we already loaded this yet? No, we haven't loaded it. Okay, let's load it. Now let's return it. If we have already loaded it, then, well, let's just get it. Let's just return it, right? So it's kind of combining these two functions almost into one. And because of that, what we can do is, instead of somewhere out in main, instead of calling load texture and then calling get texture, we could just call get texture. Every single time we could just call get texture, get texture. And so this load texture function can really be a private function. And so by making this private, it still exists and we can still use it, but everyone else, the sort of outside world, doesn't really know of its existence, and the outside world just uses this function. Say, hey, get me that texture. You got it. First, I'm going to do this check in secret. Does it actually exist? And if so, then load it, or if it doesn't, load it, and all this other sort of stuff, and return it. Meanwhile, whoever called get texture, they don't know any of that stuff is happening. They just called get texture. Okay? And so I'll get to clear in just a second. But the way, actually, no, let's just go ahead and do that now. Then we'll look at usage of all this sort of stuff. And so what clear is going to do is just empty out our map, plain and simple. So void texture manager clear textures dot clear. Simple. Get rid of all objects stored. All stored objects. There we go. Okay. And so now the way that we use this in main will change things up a little bit further. So up until this point, we've still done kind of a two-step process. Let's first load the texture and then get it. Load the texture and then get it. What if I don't want to load the texture at all, but instead I can just say texture manager get texture space. So now this variable doesn't need to factor in at all. I don't need to make a variable to store this. All I need to do is access my texture manager class. Now I'm getting an error right here because main doesn't know what texture manager is. That's because I haven't included it. And so I can bypass this whole loading process, can be completely gotten rid of. And so, I can really clean up some of these comments. That was from some earlier examples. But getting the texture and loading the texture is now all done in one line of code, or one function call, right? And so same thing right here. I can say texture manager get texture get station. We've got an extra capital E there. And really I can just copy and paste this and put that here. And there we go. Okay. Anywhere else that I need to do this, I'll repeat. Now again, it might seem like this is, a lot of additional work, and it kind of is, but we do the work up front so that later we don't have to do as much work. because now this process of using this texture manager is sort of part of how we're doing things. It's a part of how, at least in this particular example of code here. So anytime I need to access a texture, I just call this function. And because this is a static object, we can access this from anywhere, because the way static variables work, this is in memory pretty much the whole time our program runs. Static variables are very similar, although better than global variables. Conceptually, they share some similarities. They exist in memory the whole duration of our program, but it's not the same as creating a global variable. Because in order to access or change this, I have to write a little bit more code to do so. I can't just say variable x, now you have a value of whatever. I have to sort of go out of my way a little bit more. It's not to say we still couldn't abuse this. There are lots of aspects of many programming languages that can be abused or misused if people are not careful. And so let's do the same thing right here. Get texture, and we'll clean that up there. Okay, and so now if I run this, it will look exactly the same. Right? And oftentimes, as we are changing our code or refactoring our code, which is what we're doing right now, at the end of refactoring, your code will often, or your program will work exactly the same. If you've done your job right, refactoring should make your program work exactly the same as it did before. However, what's different is your code is working a little bit more differently, a bit more effectively in ideal circumstances if you're doing your refactoring correctly. And so now, if I wanted to create a new texture for something else anywhere, if I wanted to make a little spaceship or whatever, I could say sf sprite, let's say player ship, and we're going to load this up with texture manager, get texture, ship, and then I can say, if I just wanted to draw this thing somewhere, we could come down here all the way, and window.draw, player ship. Oops. And so I think it's just called ship. If not, I'll double check the file name, but I think it's just called ship. And if all of that works, then we have our little player ship right up here in the corner there. And I could load all that with just the one line of code. So now the process of making a sprite is one line of code, as opposed to 3 lines of code before, right? So this is just make a sprite, and load its texture all on one line of code instead of 3. All right. So again, the code that we started off with wasn't impossible to manage, and it wasn't even the most convoluted, clunky code ever. However, this streamlined process now, we can reap the benefits of this over and over and over again. And this kind of process is especially helpful at the start of some project. If you anticipate, well, I may have to do this 10, 15, 20 times, let me streamline it now, so all 10 or 15, 20 times that I do this or beyond will be a little bit easier to work with. And not only that, but if I wanted to add anything to this, if I wanted to add any functionality to this, then I certainly could. Let's say, for example, I wanted to change where my images are stored. Maybe for every project ever that I work on, it's not going to be this folder. It might be, but it might not be. So maybe I could do something like store a string variable in here. This would have to be a static string variable, and we could call this images directory or something like that. And so instead of hard coding this here, maybe I could have a function and say void set images directory string directory name, or directory path maybe would be a better choice, right? And so now I can set this variable and we can replace this here. So whatever the directory happens to be, then we could go ahead and change that, right? And maybe at the start of my program, of course I would still have to actually write that function, but maybe at the start of my program I could say texture manager set directory to images slash example or something like that. Or maybe it isn't this, maybe it's pictures, maybe it's a folder called textures, or whatever it happens to be, right? Maybe you have something more complex where it's like content / images / textures. And so, okay, that's fine. But now we can set this, and this will effectively be replaced here. And it just makes this a little bit more flexible, a little bit more reusable. Assuming, that texture was actually fleshed out, right? So there are lots of things that we could do to expand upon this. That's just one example. Also, I forgot to call the clear function. So the reason we need to have this clear function is if we don't, when we close down SFML, if we're running it in something like debug mode, we may get some errors when we close it. Let's see if I can reproduce that. It doesn't always happen, but sometimes. And when it does, if you've never seen this sort of error before, it can be a little bit strange, and you wonder, what did you do to break things? What is possibly going wrong on your computer? And so if we run everything and we close this, we may get this kind of error right here, and you wonder, what the heck is glcontext.cpp? I didn't write that file. I don't know anything about this. And this just has to do with the way textures are handled, the way that they get stored and unloaded, and so on. And this is all sort of behind-the-scenes SFML stuff. But to counteract all of this, essentially what we're doing is, at the end of main, clear out any textures before the program ends. And we're basically just cleaning up the mess that we made. Texture, manager, and we call clear. And that's it. So we run this now, and get out of debug mode, run it again. We won't get that error because we're properly cleaning up all of the resources that were allocated, right? So now when we close this, everything closes just fine, exited with code 0. That means everything is okay. Done. So just be sure, if you're going through this process, make sure you call clear at the end of main. And again, the clear function, all that's doing is just calling clear on our map object, right? So this is the basic texture manager class. I'll sort of pause here in case anybody wanted to implement it themselves like this. Again, I strongly recommend that you use this for yourself. It takes this aspect of dealing with SFML and simplifies it so you don't have to worry about it. Plain and simple, right? Also minus the directory variable. So we can do the same kind of process through all kinds of aspects of our code with all kinds of tools that we're working with. And a lot of programming is often things like this, especially when we deal with larger, more complex problems, right? If we're trying to write a kind of simple one-off program, we might not go to this trouble. But for larger applications, something we're working on for weeks, months, with teams of large quantities of people, we will almost always do things like this because it just makes our jobs a whole lot easier, all right? So that's it for this video. I strongly recommend that you use this for yourself.